Hi DUPHAT, I'm Ala Abdel.
And I'm Fazila Kaur.
And we're third-year pharmacy students from Al Ain University, and we're going to talk about thiolated cyclodextrins. So let's get into it. So did you know that some medicines like silymarin, they don't work well when taken as a pill? Silymarin is a compound used to protect the liver. It's a BCS class 4 drug, meaning it doesn't dissolve easily and it's poorly absorbed by the body.
This is a problem for people needing silymarin, but our research shows a way to improve how well it works by using thiolated cyclodextrin. Let's show you how it works.
So silymarin, they face two main challenges. One is that they don't dissolve easily in water, and even if they dissolve, the body will have a hard time absorbing them.
We know that cyclodextrins can help dissolve silymarin better, but regular cyclodextrins don't stay in the gut long enough for the drug to actually be absorbed properly. So the big question here is, how can we make silymarin dissolve better and stay in the gut long enough for it to be absorbed?
So that's why our goal was to make silymarin dissolve better and to keep it in the gut longer so that the body can absorb it better.
We used thiolated cyclodextrins, which are modified cyclodextrins with sulfur groups. These groups help the cyclodextrin stick to the gut, allowing more time for the drug to actually be absorbed.
So here's what we did. First, we added sulfur groups to beta-cyclodextrin using a microwave method. Then we mixed the thiolated cyclodextrins with silymarin in a 1:1 ratio and freeze-dried the mixture to form a complex. And lastly, we tested it for solubility, stability, mucoadhesion, and permeability in different lab conditions.
We also checked how the complex performed in different pH levels, like the conditions in the stomach. We tested to see its stability, how well it stuck to the mouse's intestinal mucus, and how much of the drug passed through the lining of the gut.
So before looking at the main results, we confirmed our thiolated cyclodextrin using FTIR and NMR analysis. In the FTIR graph, we saw a peak at 1,135 per centimeter, which shows that sulfur groups were successfully attached to the cyclodextrin. In the NMR graph, new signals appeared at 7.05 ppm and 4.78 ppm, confirming the presence of sulfur groups. Now let's look at the key results. First, we have the solubility graph. It showed that the solubility of free silymarin is 3 microgram per ml, whereas for the thiolated cyclodextrin, the solubility increased significantly, reaching up to 292 microgram per ml, which is a major improvement. And then we have the stability graph. It showed that the complex stayed stable even at low pHs, that is similar to the stomach's acidic environment.
Followed by the mucoadhesion graph, the thiolated cyclodextrin stuck to the gut 78 times longer than regular cyclodextrins, allowing the drug to stay in the gut for a long time. The permeability graph shows the permeability of silymarin increased by 6.9 folds with the thiolated complex, showing better absorption.
But the most exciting part is shown with the blood serum concentration graph. It shows how much silymarin enters the bloodstream after being taken as a pill.
The peak concentration was 10 times higher for the thiolated cyclodextrin complex. The total absorbed drug was 9 times higher, and the relative bioavailability increased to 39.15% compared to only 4.32% for the free silymarin drug.
So why is this important? This is important because it will lead to more effective pills for liver protection like silymarin, and it will require fewer injections, which will make the treatment for the patient easier and more comfortable.
This research shows how to make silymarin more effective, which could lead to better outcomes and lower healthcare costs for our patients.
So in conclusion, thiolated cyclodextrins help solve the problems of poor solubility and absorption for silymarin.
This approach can lead to better and more effective pills for liver protection. Thank you for watching.
Here's to making better medicines for everyone.